Okay, I'm gonna start this video anyways. There's a bird chirping outside my window and I was waiting for him to stop chirping so that I could start the video, but he's just having too good a time out there, so I'm gonna start the video anyways. Please ignore the chirping bird. If you hear it and it's distracting, I apologize, but I'm gonna start doing the video anyways. So we were partway through this problem when Zoom decided that it didn't want to work reliably for me. So let's pick up with this problem again, and then I'm also going to add in a couple of problems that people emailed in. There were several people actually that emailed in questions, but some of them were kind of the same questions, so I've kind of compiled them down into the key ideas, and we'll try to keep this as short as possible so we can hit the important stuff only. So as I was talking about with this example from last time, the first thing you have to do is identify what are the key basic statements that this bigger sentence is being built from. So one key basic statement in here is Zoom is working. In fact, you know what, let me change up and use some color coding so we can keep track of which ones are which. So Zoom is working is a simple statement. It doesn't have and, it doesn't have or, there's no negation, that kind of thing. It's a simple basic statement. So we're going to assign a letter to that. We're going to call that P. And then canceling class is another basic statement. I will cancel class doesn't have and, it doesn't have or, it doesn't have any negations or complications. So that's a basic statement. And then the statement about posting a video is a basic statement. So when you're reading through a sentence like this and trying to figure out what your basic statements are, it's a matter of which key ideas are not broken up into smaller parts. Here we have 3 key ideas that are not broken up into smaller parts. The next thing I want to point out is the comma in this sentence. Now you have to be careful because the English language can do all sorts of really creative things. So this isn't a solid rule that will protect you in all circumstances, but generally speaking, wherever there's a comma, that's a big hint about where your parentheses are going to go. So here, this comma breaks the sentence into one piece in the beginning that's very simple. Zoom is working. There's no need for parentheses there. I mean, if you were to write parentheses P, what are the parentheses doing? They're not doing anything at all. And then the comma says there's a second half of the sentence. It's connected with or, so disjunction. And the second half of the sentence is complicated. It has 2 parts in it, so I'm going to need parentheses here. The second half of the sentence says, I will cancel class, Q, and post a video, R. So the complicated part of the sentence is where the parentheses go. And let's be honest, it could be that both parts are complicated. You could say complicated thing, comma, and then another complicated thing. So you might have parentheses in the front and in the end. It's possible to have that kind of situation. So that's an example of how you take an English sentence and translate it into the symbols and how you know where to put the parentheses. Then the question was, how do you do the sentence or the truth table for it? Well, the truth table for it does not depend on what the letters mean. So forget about that. Forget about Zoom meetings and canceling classes and posting videos. Completely forget about that and just look at the symbols. When you look at these symbols here, count how many letters you're using. 1, 2, 3. We're using 3 letters. So we're going to start this problem off with those 3 letters as their own separate little columns of our chart. The other thing is, anything that you have in parentheses, or any parts inside the parentheses, they're going to need their columns as well. So because this Q and R thing is inside the parentheses here, that's telling me that over here, I need to have a Q and R column. So that's how you figure out what your columns are. You're straight up and down. The titles at the top come from identifying what your letters are. That part's easy. And then identifying what pieces you're going to need to build the big complicated thing. Now, another question that was emailed in was, how do you know how many rows you have to make? And that's pretty simple. You just multiply by 2 for every letter that you need in your expression. This problem has P, Q, and R. There are 3 letters. So we're going to go 2 times 2 times 2. 8, in other words. So we are going to need 8 rows in this truth table. So let me make 8 rows here. Oops, that was a little low. Here we go. I'm trying to make them all roughly the same size by splitting things in half. It's usually a little more consistent size-wise if I do it that way. There we go. Now, this chart we've got, this truth table here, it kind of splits into 2 key parts right here. There's the easy part on the left and the complicated part on the right. The part on the left is just a matter of filling in every possible true and false values that can possibly go in there. We've got 3 boxes to fill in for P, Q, and R, and they could all be true, they could all be false. Some of them could be true, some of them could be false in a whole bunch of different combinations. You just got to make sure you cover every single possible combination somewhere in there. The organized way that I'm going to go about it matches what the homework and what the textbook do. And what they do is, for whatever your first column is, they do the top half all letter T and the bottom half all letter F. And that sort of splits it into 2 4s. There's 4 T's in the top and there's 4 F's on the bottom. For those groups, in the next column, we split it further in half. So for the Q's, we're going to do top half T, bottom half F for the first batch. And then for the F's down here, top half T, bottom half F. Same basic idea. Oops. I'm having some pen troubles here. Let me clean that up a bit. And yeah, there we go. Much better. And then for the last column, we've got groups of 2 right next to it. So when we split things in half, it's going to be T, F, T, F, T, F, T, F. And that's a really common setup. You'll see that in every homework problem, every textbook example, all that sort of stuff. So that's the easy part. The hard part is this next part of it, because this is where things can change, and it'll depend on whether it says and or negation or if then. Here, we're doing a conjunction. That is the conjunction symbol, what usually goes with the word and. And we're doing a conjunction from this letter to this letter. In other words, we're using columns 2 and 3. And the way conjunction works is it's very picky. It only comes out true when both parts are true. So here, both parts are true, so it comes out true, but not the next one or the next one or the next one. Here's another one where they both come out true, and everything else comes out false. That's how and works. It's true if both parts are true, but if any part of it's false, then the and is false. So it comes out like this. Okay, that's the conjunction there. For this last column here, we've already worked out trues and false for the green part. Now we're trying to take that green part and do a disjunction with the letter P. In other words, this column here, a disjunction with this column here. So they're not adjacent to each other. They're 1 and 4. They're pretty spread out from each other. That's going to happen a lot. You got to get used to that. They don't have to be adjacent to each other. And with the downward pointing arrow, with a disjunction is usually true. It's very generous. The only way a disjunction comes out to be false is if both parts of it are false. So I'm comparing the blue column over there and this green column over here. And I'm looking to see if the letter F shows up twice. No. Here we go. F shows up twice here. It also does here, and it also does here. But everywhere else, we have at least one letter T, and the way OR works, at least the mathematical version of OR allows any T anywhere to make the whole thing come out to be true. So this is an example of really two different questions people are asking. First of all, how do you translate from sentences into symbols? And that was the first part of it. And then the second part was, how do you do a truth table? Practice with truth tables like this. Now, we have some other questions on practicing truth tables that we're going to do next. They're slightly simpler truth tables, but they've got some additional complications that we don't have here. So these are questions that came pretty much straight out of the homework, where students said, I have a question on this type of thing, this homework problem. There were like 4 or 5 different questions that all basically boiled down to these two things here. So what we're going to do here is for each one of these, we're going to make its own little truth table. And this is really 2 questions. So let me put a little divider line in here so that keeps it visually separate. You got 2 different problems here. It's not like one big problem overall. So for setting up a truth table for something like this one here on the left, what are the letters we have? Well, there's no R in this one. We only have P and Q. And I like to keep them in alphabetical order even when they're not in alphabetical order in the problem, like they've got Q before P. I just like to have them in alphabetical order. It doesn't really make a big difference, but the textbook seems to follow along with what I do. We're going to have negation Q, disjunction P, that we're trying to diagram up at the end. But notice that in that disjunction, one of the pieces, negation Q, we haven't talked about that yet. That's not in our chart yet. So we need to have that as its own separate little part of the chart. It's going to need a column where we work out where it's true and where it's false. So the truth table for this problem is going to have a column for P, a column for Q, and a column for the negation of Q, and then a column for the statement we're actually concerned with, negation Q, disjunction P. Okay, that's the columns. For the rows, we have 2 letters, and you multiply by 2 for each letter, so that's 2 times 2. So we only need 4 rows here. So this is a little bit simpler chart than the one we did a second ago. Again, it kind of splits into an easy part and a hard part. The easy part is where you just fill in the basic truth values for the individual letters. And then the hard part is where you deduce from those values the truth values of the other statements. So here, first column, top half T, bottom half F. It's deciding to act up on me again. Let's see if I can fix that. There we go. So top half T, bottom half F. And then for the blocks you've created there, where there's a block of T's and a block of F's, do top and bottom half as well. Why is this doing this? I do not like this weird pen trickiness that's doing to me today. There we go. Might have to keep doing that a lot. That could get annoying. And then a T there and an F there. So that's the easy setup part of this, where you just fill in the basic values. And then negation Q, you don't combine multiple columns, you just compare to an individual column. You compare to this column here and write the negation. So if that one says T, this one will say F. If that one says F, this one will say T. That one says T, this one says F. That one says F, this one says T. Negation is meant to be really easy, but sometimes people struggle with it because every other logic symbol is a comparison between 2 different columns. And this one is just looking at one column. So often people try to do negation by comparing P and Q, and that's not going to work because it doesn't really matter what P is. And then for the disjunction we have here, for the OR, we are comparing this column over here with this one here. And again, as usual, OR only comes out false when both letters are false. So right down here. Everywhere else comes out true. Now, one of the challenges that can happen with a question like this is in the computerized homework, it'll sometimes abbreviate and only ask you for this column here all by itself. They might not show this other column on the computer. You might not see that there. There might not be any place for you to fill that in. And I guess maybe they're thinking that they're trying to simplify down and just focus on the important part. What's your final result? But for your work, when you're actually trying to figure out what the answers are on paper in order to answer it, you probably need to have all of those pieces in there. So even if the computer is asking you for one part of the chart only, you should still make the whole chart so that you can get to the answer they want. Okay, let's practice those same ideas with this next one over here, because this is another one that people asked about. And I'm going to keep these both on the same screen because when I'm done with both of them, I want to talk about how they compare with each other. So what letters do we have? Well, again, just two letters. We've got P and Q. The final statement that we're trying to work with is negation Q, conjunction, negation P. That conjunction has two parts to it that we don't have in our chart yet. We don't have any columns for these things yet. So we're going to need a negation Q column, and we're going to need a negation P column so that we can, from them, deduce negation Q, conjunction, negation P. So this is going to have more columns than the one we did a second ago because it has more pieces, more subparts of the statement that we're dealing with. And then, just like the previous problem, there are two letters. So we're going to need 4 rows. And the basic setup for true and false looks like this. And then we get to the hard part. So for negation Q, we just take whatever's in the Q column and we write the reverse letter. So that's a T, that's an F, oops, I miswrote something. See, this is why it would have been better in a Zoom meeting because somebody would have jumped right in and corrected me there. But here, you didn't get a chance to jump in and correct me. I had to correct myself. So that's how they come out. They're the exact opposite of the Q column. For negation P, look way back over here at the P column and do the negation of that. So that would be an F at the top, another F, and then 2 T's at the bottom. And then this last column is an AND. It's a conjunction, and it's a conjunction comparing these two here. So conjunction, remember, is picky. It only comes out true when both parts are true. So that would be these two down here. Everything else has at least one part of it false, so all the rest of them come out false. It also changed color on me. That was really weird. I don't know why it did that. So if you take a look at this and you compare these two problems, one thing that I want you to notice is the columns that you're using have to contain the simplest pieces first, and then one step up in complexity, and then at the very end, the full complicated statement that you're dealing with. You have to sort of step your way up in complications as you go. If you skip the columns in the middle and try to jump straight to the end, sometimes you can do it. I mean, honestly, truly, you can do that sometimes. Sometimes you can just think real hard and figure it out. But I'm hoping you can start to imagine that as these statements get more and more complicated, it's going to become impossible to do it all in your head. You should practice now while the problems are easy. Practice setting them up one column at a time and filling in stuff, even if maybe you don't really need to, just to make sure that you get used to it for the tough ones. Now, there were a couple of other questions that we're going to talk about here in a second that have to do with the very last problem from the homework. And I've sort of stolen out a couple of key parts of this problem so that I can illustrate what's going on here. I think, based on the questions that I was getting on problem 7 in the homework, I think people are doing the problem the wrong way. A lot of people were talking about how do we diagram up something that has this many different statements. I'm going to use P and Q and R and S and T and U and V. What, this is kind of excessively complicated. What were you thinking, Mr. Adams? Well, the thing is, there's nothing in this question that asks you to do any truth tables at all. So if you started to make a truth table, my suggestion is stop and read the directions, because not every problem is the same as every other problem. Problems are all different from each other. And sometimes a problem is doing something much easier than you think it is. So here, all I really was expecting you to do with this problem is not to diagram it up. It doesn't ask for a diagram. You don't have to make any truth tables or any of that kind of stuff. All I was expecting you to do with this problem is back up and use, sort of some common sense, but be organized about it. So here, when you read the first paragraph in question 7, it's describing something pretty complicated. It's describing a very complicated special deal where you get extra cheap airplane tickets. But in order to get these extra cheap airplane tickets, you have to meet a whole bunch of different requirements. So what I've noticed among people just in day-to-day life is when they're faced with a problem like this, when they're faced with some sort of description like this, they just don't even try to attack it at all. So I'm putting this in your homework to kind of force you to try to think about this, because I bet you when we're done with this problem, you're going to realize this is way easier than you thought it was. So yes, you read that paragraph and it looks tremendously complicated and your mind gets all blurry trying to think about it. Well, here's how you deal with that. Don't try to think about it all at once. Stop and break out each part of the problem, each little requirement, one at a time, and sort of make a little list. Make a little chart of your own, not like a truth table or anything, just a little list of what the requirements are. So when I read this paragraph, I see tickets must be purchased between January 1st and February 15th, and other stuff. So in my mind, I'm seeing this is one little part requirement that has to be met. So I'm going to write that down as its own little separate thing. Like you could make bullet points if you were typing in Word or something. Purchase between Jan 1 and Feb 15. That's one of the requirements. And there's going to be more. I'm going to keep track of them. Okay, what's the second requirement? Well, the second requirement is that they have to fly round trip between March 1 and April 3. So that's our next requirement. Fly between March 1, April 3. Okay. What's the next requirement? Departure must be on a Monday, Tuesday, or Wednesday. So depart Monday, Tuesday, Wednesday. Okay. Next, return must be on Tuesday, Wednesday, or Thursday. And then there's this extra little requirement at the end, stay over at least one Saturday. And as you're kind of reading through and picking out each little requirement, do just what I did here. Like write a little abbreviation, make up a little bulleted list, or make little check boxes or something like that. Just keep them separated. Because the reason this seems complicated is because they're all mashed together in one giant paragraph. That's why you think it's complicated. But it's not. Just pull them out individually. So although this isn't making a truth table, we are using the skill of reading a paragraph and identifying the simple pieces. That's the same as we did when I took the original problem we started off today with, where you find the simple pieces. And this has 5 simple pieces in it. And then when you're going to do a particular problem, like Gina plans to purchase her ticket on da-da-da-da-da, what you do is you go through each requirement one at a time and figure out whether that requirement is met. So for the purchase requirement, the purchase requirement was that they had to purchase between January 1st and February 15th. Well, February 8th is when she's planning to purchase her ticket. That's good, so that's a yes. That requirement has been met. And then go to the next requirement. Next requirement says that they're going to fly between March 1 and April 3, sorry. So here, fly between March 1 and April 3rd. Well, she's going to fly on March 10 and return on April 8. Oh, look at that. April 8. So the requirement about when they're supposed to do their round trip between March 1 and April 3, she's not going to meet that requirement. So we have to look at the other requirements, because when we're answering this question set is basically saying, why does she not get the special deal? And if you tell her it's because you're coming back on April 8th, she might think that all she has to do is come back sooner and she's good. But maybe there's another problem too. So you're not really helping her as much as you could help her if you don't go through and figure out all the problems with her plan. Because really, if you want to be fair to her, if you want to be helpful, you've got to tell her all the problems that need to be fixed. So let's go through the other requirements. We've got this requirement about the departure. Departure is supposed to be on a Monday, Tuesday, or a Wednesday. Well, she's departing on a Tuesday, so that's good. She's supposed to return on a Tuesday, Wednesday, or Thursday. Well, she's returning on a Wednesday, so that's good. And then this last little bit about staying over at least one Saturday. And this part seems trickier than it is. You might think that you have to go get a calendar and take a look at it and see, okay, where's March 10 on the calendar? Where's April 8th on the calendar? And maybe it's not even on a Tuesday like it says it is. So then you realize you're maybe talking about a different year. That's not at all the idea. All you're expected to do here is look to see, does she stay at least a week? Because no matter when she shows up, if she stays at least a week, there's going to be a Saturday in there somewhere. It's unavoidable. So if she's going from March 10 all the way to April 8th, that's almost a whole month. There's definitely at least one Saturday in there. So for the question about stay at least one Saturday, that's also a yes. So it turns out that of the 5 requirements that have to be met here, she's only really failing on one of them. It's the return day on April 8th doesn't meet that requirement. So this is how I was expecting folks to do question 7. I'm not asking you to do any math symbols. I'm not asking you to make up any tables or use the words conjunction or disjunction, but you'll notice that we are kind of using the ideas from this chapter. We are using the idea of finding basic statements inside of a paragraph. There's also or showing up in this place. Remember, Monday, Tuesday, or Wednesday. We just sort of instinctively did that without having to break out, this is a disjunction and it's true if this blah, 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 blah. So really what I'm trying to show you here is you already know how to work with ands and ors. Don't make this a bigger deal than it is. We've also got conjunction going in here because these 5 requirements, they're all and. She's got to do this, and she's got to do this, and she's got to do this. These are all ands. So this problem, this has conjunctions, this has disjunctions, this has basic statements inside of a complicated statement. So even though it's meant to be done in this fairly common sense, casual, easy way, it's still a pretty important question to bring together the ideas that you're learning here. All right, folks, this gets us through the various questions that were emailed to me in time for me to put them into this video. And hopefully this will be at least as good as what we were going to be doing in Zoom today. I've come up with, I think, a technological fix for the problems we were having today. So on Monday, I'm pretty sure things will be back to normal. But if not, then we always have this as a backup if we have to. All right, folks, have a good weekend, and I will see you on Monday.